Welcome viewers. Our lesson today is on volume and scale factor. And now we are going to tackle on questions related to volume and scale factor. And our number one is, given that the two boxes are similar, calculate the volume of the large box if the small box has a volume of 15 milliliter. Now, as you can see, we have two boxes which are in the shape of a cube, if I'm not wrong, and of length, the smaller one 2 centimeter, bigger one is 6 centimeters. Now we have been given 15 milliliter as volume of the smaller box, and now we need to relate the volume and scale factor. In that, we need to find the scale factor first, and with the scale factor we cube it to get the volume scale factor, so that with the volume scale factor we will be able to now find, or rather calculate, for the volume of the bigger box. Now calculating on the scale factor, of course it is the enlargement scale factor, which is the image length over object length. The image length is 6 over 2, and 2 is the object length, so it will be 3. That is the scale factor. And so to find the volume scale factor, then we say volume scale factor is equal to linear scale factor cube. So that means that we are going to take 3 cube times 15 so that we get the volume of the larger box. So that will give us 405 milliliters. Now number two, the diagram below shows two jugs which are mathematically similar, and the smaller jug is of height 20 centimeter, bigger jug is of height 30 centimeter. Now the volume of the smaller jug is 0.8 liters, that is the amount it can hold, and find the volume of the larger jug. So we are going to find the scale factor. We are going to find the scale factor because we are told they are similar. So we compare their length, we get the ratio. So this will be 30 over 20, that will be 3 over 2 as the scale factor. And we have been asked to calculate for the volume of the large jug. To get the volume of the large jug, that is now where we compare the volume and the scale factor, because we cannot use the linear scale factor to find the volume. Now we need to change the linear scale factor into volume scale factor. So that will be 3 over 2 cube, because we have that volume scale factor is equal to linear scale factor cube. So it will be 3 over 2 cube times the volume of the smaller one, so that we get the volume of the larger jug. So our answer in this case will be 2.7 liters as the volume of the larger jug. Number 3, the diagrams below shown are the diagram below shows 3 similar popcorn packets, and part A of our question, write down and simplify the ratio of the sides of the super duper to the big sized packet, and the super duper to the medium size packet. Number 2, or rather part B, the super duper box needs 1,600 square centimeters of cardboard to make it. How much will the big box need? That is our part B. Finally, part C, the big one holds 2,700 cubic centimeter of popcorn. How much will the medium one hold? Now, we need to find the ratio of the super packet and to the big sized packet, and we are going to compare their length. We are going to compare their length because they are similar packets. So it will be 16 compared to 12, that is 16 over 12. That will give you, if you simplify that, it will give you 4 over 3, and in ratio form it is 4 to 3. The other part, the super duper box to the medium box. So we again compare their length because they are similar, and so it will be 16 compared to 10. That will be 16 over 10, and that will simplify to 8 over 5. In ratio form it is 5, it is 8 ratio 8, sorry. Part B, we have been given that 1,600 square centimeters is taken by the super duper box. Now we are supposed to calculate the area that it will be covered by the big box, the area covered by the big box. Okay. So in this case, we need to find the linear scale factor, the linear scale factor in this case. And then for us to relate the scale factor and area, then we need to get the area scale factor so that we'll be able to get the other area of cardboard needed. So the reduction scale factor here is, it will be 12 over 16. That is reduced to 3 over 4, and in ratio form is 3 to 4. So 3 over 4, we need to find the area scale factor so that we multiply the area by the area given, the area scale factor by the area that we have, to be able to get the area of cardboard required by the bigger box. So area required by the bigger box will be 3 over 4 squared times 1600. So that will be 900 square centimeters. 900 square centimeters. Let's move to part C. The big one holds 2,700 cubic centimeter of popcorn. How much will the medium one hold? So again, we are going to find the linear scale factor between the bigger and the medium. So it will be 5 over 6. So 5 over 6. And so to find the volume, it will be 5 over 6 cube times the volume given, so that you find the capacity for the medium one. And that gives us 1,562.5 cubic centimeters. Number 4. So walls make two sizes of the cones. Yeah, I think they are cones, which are similar. The small one cost 40 pounds. What should the big one cost? Now, these are two cones and they are similar. So it's the concept of the linear scale factor. So we get the scale factor first, which will be 12 over 8. That is 3 over 2. So we can get the volume of the large jug or the large cone. For this case, it will be the 3 over 2, cubed times 40. And this will give us an amount equivalent to 1.35 pounds. 1.35 pounds. The last question, the ratio of the volume of two spheres is 1 to 10. What is the ratio of their surface areas? And there's a condition, answer to one decimal place in the form 1, 2. So in this case, we have been told that the ratio of volumes. So it means if these are volumes, then we are dealing with the volume scale factor. So we need to get the linear scale factor from this. So we have that the linear scale factor cube is equal to 10 over 1, or rather is equal to 10. So to get the linear scale factor, or rather the scale factor, then we need to cube root 10. So cube root of 10 is 2.1544. Then we have been asked about the surface area. So with the scale factor, we need to find the linear scale factor, area scale factor by squaring the scale factor. So surface area ratio will be the scale factor squared, and that is 2.1544 squared. And our ratio is 4.64. So to get the ratio of their surface area, then it should be 1 ratio the answer that we have just got above there. So 1 ratio 4.6. We have rounded to 1 decimal place as put by as per the condition in the question.